Okay, so in this video we are finally getting to the good stuff, okay? So we are going to put a lot of skills together. That we've been covering all these different skills with complex numbers and polynomials and division and all kinds of different things, and now we're going to start wrapping those into a problem together. It's actually kind of fun. The vocabulary up here, make sure you are paying close attention. Part A, they're referring to the product of linear and irreducible quadratic factor. Okay, those are words that you're going to see again, and you're going to see those in WebAssign, and you're probably going to see them other places in the lab manual and maybe on an assessment. Part B, it says determine all real and non-real complex zeros. You'll see those words again. And part C is referring to a product of linear factors with complex coefficients. Okay, so we'll talk about these more as we progress through the problems. I just wanted to bring those to your attention. So what they're asking us to do here is to factor. Okay, and they're giving you some type of function and you've got to use your factoring. So I'll show you here, like on this particular one, we can pull out a z, factor out that z, all right, and then we will have this outcome. And this is actually the answer to part A, okay, because this is what we call an irreducible quadratic factor. And what that means is it's obviously quadratic, okay, but also we cannot factor that further just using like regular factoring skills that we already have. Okay, it's what we call a prime trinomial, as far as you can't take that and use the factoring that we already know how to do to break that down further. Okay, so moving on to part B is they want us to determine all the real and non-real complex zeros. So for part B, I am going to list out the zeros. Well, this z out front gives me a 0 of 0. Okay, so I can go ahead and list that out. The fact that I have a third degree polynomial means that I'm going to have 3 zeros. Okay, so there's 2 more out there that I need to find. Okay, and since this guy right here, this irreducible quadratic, I can't solve that using factoring, I'm going to have to go to the quadratic formula. Okay, so real quickly over here to the side, I'm going to write that out. Okay, once again, this is a skill we've already covered, but now you're actually using it to do an actual calculation. Okay, and be careful with simplifying your root. We have already worked on this in some previous videos, but still be very, very careful. In fact, right here at the very end, just to remind you, this is a review. When you are dividing out this 2, make sure you divide it out of both of those top places. Okay, you cannot divide that 2 into the 10, but you can divide it out of the -6 and the 2, and you should do so. Okay, so what we just got here was our other 2 zeros. I'm actually going to make this a little bit bigger so I can write these in here. I got a 0 of -3 plus the square root of 10, and then -3 minus the square root of 10. Okay, that's a 10. All right, so there are my 3 zeros. Okay, and then part C, it says write the polynomial as a product of linear factors. Okay, so linear factors means that we're going to basically write this in what we call like root form, where you write a factor for each one of your zeros. Okay, so I have z. Okay, that was my first factor that gave me the 0 of 0. Okay, and now I can say z minus, okay, and I'll put this -3 plus square root of 10 in there, and then I can say z minus, okay, the other 0 that I have. Okay, so since I have 3 zeros, I need 3 factors. And basically you just make sure you put the z minus the root, okay? Z minus the root. And we've done this before. It just feels a little different now because the numbers are getting kind of messy. And this first one you can just leave it as z, okay? And there you go. You have done part A, part B, and part C. Now for number 2, you have to start this one using grouping. I'll just give you a little hint here that with grouping, you put it into 2 groups. Okay, and then you proceed with your factoring using grouping. That is a prerequisite skill, and that might be something if you don't remember it or you need some refreshing, you might need to Google that and do a little studying on that. Okay, and that is called factoring by grouping. Okay, and then you just want to keep factoring this more. I'll give you a hint on number 3 here. This is a trinomial, and you can factor it into 2 binomials, and instead of having an x and an x, you can use an x squared and an x squared, and you just want to finish that factoring there. Okay, and then a little hint on number 4 is you have a GCF of t squared. Okay, so you want to start your factoring by factoring out a t squared and then continue the problem from there. Okay, so I try to give you a little hint so you can have something to help you get started, but make sure you work on these, and you're basically just trying to get part A, part B, and part C done for each of those. All right, now if we go over to the next page here, I'm going to jump down to this problem because this is one of the more challenging problems, so I thought it would be good if we did this together. And what we're doing here is we are literally putting about 6 or 7 skills all together in one problem. Okay, so first off, we're going to use our division to show that x squared minus 1 is a factor of g. Okay, so we do have to use our poly long division, and if you want, you can put a placeholder out here in the divisor if you want. That's fine. You don't have to put the placeholder out there, but a lot of students do and find that to be helpful. All right, and then you write out your g of x function inside the division, and then you proceed with your division. So you're doing x to the 4th divided by x squared, which gives you an x squared. You write it on the top, multiply it through, and then you subtract that quantity. The x to the 4th subtract out, you'll have a 2x cubed plus 6x squared. Be careful with the subtraction. Remember, the subtraction distributes through. Okay, bring down the next term and cycle through your division again. So you're doing 2x cubed divided by x squared, which gives you a 2x. You write it on the top, multiply that through, subtract that quantity, and be careful right here because these actually do subtract out, and if you want to put a 0x in there to hold that spot, that's fine. And then lastly, go through your division one more time. You're going to say 6x squared divided by x squared, which gives you a 6. Multiply that through, subtract, and we are going to have everything subtract out, so we'll get a 0. Okay, so we kind of knew that was going to be a 0 when we started the problem because of the way the directions were. The directions said using division show that x squared minus 1 is a factor of g. So remember, whenever something is a factor, you get that remainder of 0, and so just the way the wording of the problem was, I was expecting a 0, but they wanted us to show that. And then they're asking, what is the quotient? Okay, well, this thing on the top here, that is your quotient. And so just to kind of help you understand where we're at this point, I can rewrite my g of x function as x squared minus 1 times that quotient that we got when we did our division. Okay, so we starting this factoring process of g of x. And if you look at part B down here, it says determine all real and non-real complex zeros of g. So g of x is a 4th degree poly. So you're looking for 4 zeros, okay? And you kind of have to just kind of get to those zeros either using your factoring or your algebra. Now this first x squared minus 1, that can be factored down to x plus 1, x minus 1. And the benefit of doing that is that tells you you have a 0 of -1, and that factor tells you you have a 0 of 1. So that gives me 2 of my answers, okay? And then I'm just looking for 2 more. I'm going to have to get my other 2 from this, okay? But this is what we call the irreducible, right? The irreducible quadratic, meaning that I can't use just regular old factoring to break that down. I'm going to have to go to my quadratic formula and see what I can do with that. Okay, so a student actually found a mistake on my previous video, and so I'm going to redo this part. Okay, so over here was all of the division, okay, work. I just did not copy that over again, okay? But that got us to where we're at now. And we're doing the quadratic formula, okay, to figure out the roots of this trinomial. So you want to do your negative b plus or minus square root b squared minus 4ac, as we've done many times already this semester. And you get a negative number inside your root here. And that means we're going to have to use our what we know about complex numbers. Let's see if I can squeeze it in here. You're definitely going to need to bring out an I, right? So let's see here. Since we have a negative, we're going to have to bring out an I, and then you want to think about simplifying your square root of 20, which that's what I did wrong on my previous video. I made a mistake with simplifying that. So you need to bring out a 2, and you leave a 5 in there, and you also have an I on the outside as well. And then you can simplify out your 2. So, so 2 comes out of itself once, and you can divide it out here and here as well. Okay, be careful with that simplifying. And then you have -1 plus or minus I on the square root of 5. Okay, so those are our other 2 roots here. So -1 plus I on the square root of 5, and -1 minus I on the square root of 5. So we have found all 4 roots at this point. All right, and so now we need to do this last little step down here where we write g as the product of linear factors with complex coefficients. So basically we just want to make sure we write g of x out with each factor listed separately, okay? So you're going to have your answers that we had up here, right, earlier, the x plus 1 and the x minus 1. Those are linear factors, okay? But instead of listing this guy out, that's a quadratic factor, we're going to use these 2 roots here, okay? So we already used this root and this root when we did these first 2 factors, and now we're going to use these other 2 roots, okay? And just be careful the way you write these. All right, so you can see I took this root and I stuck it in there, and then I took this root and I stuck it in there, and you always use your x minus the root, right? X minus the root, and just be really careful that you're adding these parentheses in here, okay? Because of the subtraction, you want to make sure you have those parentheses. And you can simplify that further, or you can leave it like that. Either way is okay. Obviously in WebAssign, make sure you read the directions of how they want you to write it, but for us, like in the lab manual and stuff, what you have here is okay. All right? So anyway, anyway, I hope you are enjoying seeing all these skills get put together. I think it's kind of fun when all of the different things we've been working on start coming together in a problem. So hopefully you're enjoying that.